Welcome to the webinar. My name is Richard Buck. I'm application engineer here at Transoft Solutions in Rotterdam in the Netherlands. This is the agenda for today. Now by the end of this session, I've shown you the basic functions and features that will allow you to analyze spatial requirements of your specific road design projects. And we can do this by generating different kinds of vehicle simulations. Just give me a short moment to change to my technical presentation window. Okay, so here it is. So within this drawing, I'm going to place a simple simulation in a minute. Now, before I do that, let me quickly show you the vehicles that are provided with AutoTURN. So in our vehicles window, here on the left you now see a list that is filtered on available libraries. So there are more libraries available also from regions outside of the European regions. So we have much more vehicles from the Americas and Asia, but I've filtered the list now to only European libraries. So if you would be working on a project, then first you would select your vehicle from a certain design guideline. As you can see, the guidelines here we have here are from the Netherlands, from the Czech Republic, UK, France, we have them from Poland, Israel, Italy, Finland, Spain, Austria. We have a special transport library for wind blade vehicles. So all regions are represented here. Now if you would feel like this list is not complete, then we always appreciate it if you would notify us of this information so that you can add it in a future version of AutoTURN. Now once you have a vehicle selected from the library, so in this case I have this articulated bus from this generic architectural library, you will immediately see a preview of this vehicle, and you can also look into more detail to what the dimensions of this vehicle are, tire sizes, etc. So everything into the detail is available to be viewed. You can create your own vehicles by copying them and making modifications to those dimensions. I will not go into that during this session. Just to inform you that this is also possible. If you have a special vehicle, you can always create it. So let me start with a vehicle, let's say coming from this guideline here, and I'm going to choose a, let's sort this on the vehicle name. On this passenger vehicle that's going to drive into this parking deck, and I'm going to do that by using this group that we have available, which are called the Smart Path tools, and the first one is my generate arc path. So I will touch the other commands as well. First let me start with this one, and the Smart Path tools allows me to place a vehicle anywhere inside my drawing, and then I can give it a certain alignment and move forward with that. Now the way to do that easiest is to use this big geometry tool, which allows me to select this line work here, and then let me zoom in a little bit. Then I have this directional arrow available that allows me to either go left or right with this vehicle. So I want to go into this direction. So when that's aligned to the line work, I can position it here, and then I can start my simulation. So the arc path window changes into the Smart Path tools, where I can see placing a forward simulation with this vehicle that has a certain steering lock angle that would result in the correct turning radius. I'm going to increase my speed to 10 kilometers per hour, and then I will move into this direction. Curious what that is, but I'll find that soon. So what I can do is just navigate my vehicle in any direction, and then what you will see is the resulting radius of the vehicle. And what I want to do is go into straight section, and I will go into this direction right here. So just before I go and make this right hand turn, there's something else that I can do. And that's turning off this this message here, which is not necessary at the moment. Let me quickly turn that that off. Okay, let's try this again. So here we are. I'm placing my vehicle on this line into this direction, and let me just place it here. And before I move into this right turn, I can turn on the so-called preview arc path, which already gives me a good indication where this vehicle reaches the maximum turn, or what the reach is of this vehicle. I'm trying to pan here. And I think at this point I would find a good radius for my vehicle to start turning. So then I can turn off this force straight line option. Can turn off my preview arc path for now, and then I can see that my vehicle is moving nicely into this direction. And from there, again, I want to go to this location. Just let me point and click here. Then I'm going to align my arrow into that direction. And turning on my force straight line option again, because I have this straight section that I'm following here. Also because I'm on a straight, I can just make a minor modification or just some fine-tuning by enabling this turn wheels from stop, so that I can just reach this straight line a little bit better. Then I will turn off that simulation again. Here we have a point where I can steer in just a little bit later to align my vehicle to this driving path. Do that again right here. Once more, and over here you can see that I just steered in a little bit too late. Well, there's no problem. I can always undo my last segment and then place the vehicle here again. Just align this nicely again with this upper driving path. And from that point again, I'm going to turn on my force straight line, enable the turn wheels from stop to get a nice straight section there. And yeah, I've driven around this center centerpiece of this parking lot, just moved around it by using one command and giving me all the flexibility to move this vehicle into any direction I'd like it to go. Okay, so in this text example, I want to show you the next smart path tool, which is the generate corner path tool command. Before I do that, I will switch to a different design vehicle. As you can see, I still have my passenger car selected, so let me quickly change this to something. Let's say from this French guideline, which is this semi-trailer vehicle. I'm going to click on OK and start my generate corner path command. Again, I can align the geometry to align the vehicle to existing geometry. I can also place the vehicle. Let me show you how that works. Then I can still adjust the orientation a little bit, or I can just enter a vehicle start angle if I know that value. So in this case, it is 0. That gives me a nice alignment to the right. And I want to make this vehicle turn into this direction. So especially for 90-degree angles or angles that you know the value of, it's very handy to do this in one go. And in AutoTURN, in the corner path window, we have this option which is called select sweep angle, also allowing me to select some existing line work. So I'm going to select the line work representing the curb on this side. And once I do that, immediately AutoTURN has information to calculate that angle so that I can make this vehicle nicely align and turn into this direction. Now the radius at this moment is quite small, as you can see. This is because the radius is coming from all the vehicle parameters that were entered and were specified by the guideline. So this minimum turning radius is something that the command defaults to. But in this case, a turning radius of 25 meters would be a bit more comfortable, and also will still use safe maneuvering to do that. Now as you can see, 25 meters, that looks pretty good. I can still increase this to 30 if necessary to get an even more comfortable turn. And once I do that, I just place the vehicle like this, and I've performed this turn with just a few clicks. So that's a very easy and simple way to go around that turn. Now the next thing I will do is just to repeat this command, and now place a simulation where my vehicle is coming from this direction. So now I want to choose my pick geometry function again. Just always the easiest method to place a vehicle. Let's line it up here, and I want to do a right-hand turn. Again, I'm going to pick the sweep angle or the line to calculate the sweep angle. And as you can see right now, when just trying to get the best images as possible for you. So now when I place this simulation and align my vehicle, move it a little bit away from the turn, and place it like this and end the simulation, then you see we have a little issue going on right here where our vehicle is yeah, touching the curb. So at this point, I can only see that yeah, there is some line work colliding with this curb right here, but I don't know what information this is. So to show you, I can go here into my display properties, and in the envelope section, I currently have the envelopes on for only my vehicle body, which is the blue line that you see here. And to get a little bit more information, what actually is touching the curb there, I can turn on the front and rear tires. I'll disable the display for my vehicle body for now and just update the simulation. Once I do that, it immediately updates. Let me close this by clicking on OK. And you can see that here in yellow I have my front tires going nicely around that turn, and in green we do see that our rear tires are yeah, will be causing an issue right there. Now, to still make sure that we can perform a simulation like this with the same vehicle, I can also choose to make this simulation, but now with my AutoTURN corner path command. And what this command actually does is pretty much the same as the normal corner path, but now what I can do is use a little bit of oversteer, where the driver is actually counter steering to create some room on the inside of the curb and then moving around that turn. As you can see, already the values that I have here for my entry offset and exit offset appear to be okay. Now let's choose to use a 1 meter offset and then make this turn. Now, and as you can see, this allows me to place the vehicle and get it around this turn without any problems. So when I place this vehicle right here and I want to analyze this a little bit better, then I have this so-called place vehicle command, and place vehicle just give me some real good visual feedback on what and how this vehicle is moving around that turn. Sorry, that was my right mouse click. So at this beginning, so when it touches this stopping line, you can see that the driver is first moving left. So at this point, where you see my blue steering pointer, we have an so-called entry offset. So that's the value for the entry offset. So the driver drives to the left for 1 meter and then turns to the right. Now look at the rear wheels. So they're now turning in quite nicely. Also here at the top, you see that my wheels and my vehicle body, they stay clear of any obstacles on that side. And the vehicle passes this quite nicely. So that's the example for oversteer path. Then we have our steer a path command, and this is sort of a more free method to make this vehicle drive from one position to the other. So at the point that I now start my vehicle, the vehicle follows my cursor and then moves in this direction. So it takes a little bit of practice. but as you can see, it will produce some results. So as long as you're moving the mouse, the vehicle will drive toward your mouse or cursor position, and then you have a simulation that looks a bit like this. So it's a little bit wobbly, as you can see. It's not the best one that I've done, but this gives you a good idea of what steer a path allows you to do. All right, so let me switch to another example. So up to now I've been showing you my simulations where they would only consist of one type of simulation. But the great thing about all of the SmartPath tools is that we can easily combine all the types of simulations we have available here. And just to show you how that works is, in this example, I have my semi-trailer that needs to go into this loading and unloading area where I first want to use as much space as possible to get a comfortable turn for this vehicle. I'm going to do a straight section again, and maybe at this point I'm going to do it like this again, do a little straight, and I want to get my vehicle aligned to the next part, which is a reverse simulation. So at this point I want my vehicle to reverse into this bay right here, and there are multiple ways to get my vehicle in that dock by just simply dragging the cursor through the rear axles of my vehicle and then moving it into this position right here. Now the easier way, so this works similar to the forward arc path maneuver, but now you'll do it in a reverse maneuver. But if I just undo my last step, the simpler way to do to get an angle on the turn that we want to achieve is also by changing from my reverse arc path to a reverse corner path simulation. And what I have then is also this sweep angle function, also allowing me to select existing line work. AutoTURN then immediately aligns the vehicle to that line, and as you can see, we immediately have a nice alignment, and AutoTURN does all the calculations in between. So that speeds up the process drastically, and also keeps your simulations clean. So after that, I've done this reverse simulation. I can leave this dock again, performing a forward simulation. And as you can see, I'm still in the forward corner simulation with the previous sweep angle. Let me quickly move to generate arc path again. Go into this turn. Turn this thingy off. And as you can see, I just used a little bit too much space there, so I'm going to undo that. This one too. So I'm just looking at my rear wheels that they're not touching the divider and the vehicle that we see there. And I can leave this dock again like so. So I got a forward arc path simulation, then a reverse corner simulation, and then I'm leaving the dock again with a forward arc path simulation. Okay, then let me show you another example. Okay, so here is my next one. So in this example, I quickly want to show you our feature for placing an adaptive simulation. So adaptive simulation is something that you can use to easily select already existing line work. This can be a center line of a road or a road curb where you want your vehicle to follow that object. So in this case, I've selected this line. So this is a polyline, and when I just zoom in a little bit, you immediately see that the vehicle is centered on that line. It's also linked to the geometry, which means that if there's any change in this polyline, then also the simulation will automatically adjust to that. So in this case, if I want to place it with an offset, I can choose to offset it to the right, or I can offset it to the left of this line. So in this case, I want an offset from this curb, and just let me put this to 1.5 meters, and immediately that will update, so I can increase or decrease this value even, so that it's actually on that line. In this case, let's make it 70 centimeters. And immediately gives you the opportunity to place this simulation really quick based on some line work there. So I'm linking it to the geometry. Let me just give this 1 meter offset so you will see a little bit better what's going on. I'm going to click on OK, and just zooming in one tiny bit. I can just pick up this line and place it roughly here. And as you can see, the vehicle simulation immediately updates. So there's no long calculation time, it's just immediately there. Then to do this on this example, I'm going to place this adaptive again, and do an offset to the left, also with 1 meter, and I'm going to click on OK. And it's just a really good example on how to test vehicle simulations and see if there's enough room available in a scenario where we have a road that has a radius of 50 meters and also has a total width of this 7 meters. Place adaptive simulation again. Select this line work, do an offset to the left again, and click on OK. So what I've done now, I just selected both curb edges. I could have also selected the center line, and in that case, if I did some modifications to the center line, then both simulations would have updated automatically. As you can see here, there's no collision occurring between these two vehicles, so that's safe for now. All right, then going to my last quick example, which is in this area. So very similar to what we saw with the adaptive simulation. is the vertical simulation. So as I mentioned in the beginning, with vertical simulations, what you can do is just draw some line work representing the terrain. And on this profile terrain line, we can also place a vehicle simulation. So we do that with this vertical simulation tool. So the line work that is here is something that represents the terrain that we see in this top image. So I'm choosing vertical simulation, and I select the line on the side where this vehicle needs to start. And immediately AutoTURN takes all the information from the terrain line, takes all the information from the vehicle properties, and is able to generate this profile, as you can see here. So everything can be formatted in your own style according to colors and line styles representing your office preference. And once this information is there, we can just place it. And also here we had that option to link the simulation to the profile line, meaning that if something would change in the profile, then also the simulation would follow. Now going to the right side, we have another profile with a little bit of a building overhang here or any other overhead obstacle. Once again, when we do this vertical simulation, we can test multiple instances. So in this example, we see that we have some conflicts. We have some ground conflicts here when going down this ramp, and also when leveling again, there's a little obstacle. Then we have a conflict there, and we can easily adjust those. So the way to do that is simply by clicking on OK. So I'm still confirming the simulation, and with some basic AutoCAD commands I can make some adjustments here. So what I need to do is just enter a little bit of a top and bottom radius here. I'm choosing the radius of 15 meters. So immediately when that information is modified and as the simulation is linked to the geometry, it will recalculate and see that there's no obstacle at this point. So let me just redo that. Fill it again. Do that for the radius. That's 15. And also when this radius has been applied, we have one less conflict. Now just to zoom into that area, you can see that it's a little bit small, this safety, but at least it complies to this safety issue. And the next thing I want to do is this. So on this side we still have an issue right there. Now the way to solve that, also simply modifying the geometry. So if I stretch it out of that safety area, let's just shorten this with roughly 3.5 meters. And the geometry is not linked to this obstacle layer, so now that I've made changes to this other element, I can manually generate or regenerate the simulation. And let AutoTURN do the check, and as you can see, this gets rid of my conflict right now. So yeah, with that vertical simulation, with these two examples, I've come to the end of the technical presentation. So let me switch back to my PowerPoint view. Yeah, this version I showed you was the latest one, so that was AutoTURN 10.2, and it supports the CAD software or CAD platforms that you see on screen. So we have AutoCAD from 2010 to 2019, also for Civil 3D, the Microstation, V8i, and Connect, the Power Draft, Power Civil, GeoPack and Inroads versions, also the Ecom EcoSim Building Designer version is supported, as well as OpenRoads Designer. BricsCAD version 16 to 18 in Pro and Platinum, and ZWcad 2017-2018. Now, in case that the 3% that had a different CAD software, let's say you're an Allplan or ArchiCAD, or maybe you only have Revit, Vectorworks, or TurboCAD, then and you would need to have a tool for turning path analysis, then I just want to highlight AutoTURN Online shortly. So AutoTURN Online allows you to quickly and easily perform accurate turning path analysis, and this you can do directly in your local web browser. And you don't need to install specific CAD software additionally. So here's how it works, and that's in actually 3 easy steps. So the first step is to import a base plan, and this can either be an aerial image or a DXF file. Then in AutoTURN Online, you choose the right design vehicle for the scenario, and step 3 is to simulate forward and reverse movements. And then you can save the drawing and export the simulation back to your AutoCAD software, and then overlay the simulation within the original drawing file. So AutoTURN Online still offers essential tools to review designs, test concepts on a sketch or an aerial image, but also allows you to do simple detailed design. Now, as long as you have an internet connection, you can access AutoTURN Online, and you can do this anywhere and anytime. So if you would like to learn more about AutoTURN Online, just go to AutoTURNOnline.com and give it a try. Now, for now, let me wish you a very pleasant day, and we hope to see you next time. Thanks. Bye-bye.